Algebra 1, this is our second day of solving systems of equations by the graphical method, okay? So let's look at this. I got a triangle here on the coordinate plane. Each of the points A, B, and C are the solution to a linear systems of equation. Label each side of the triangle with its slope. Give the systems of equation for each vertex of the triangle. So let's just figure out the slope. If I look at points A and B, then the slope is going to be 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So that's going to be 6/4 or 3/2. So double check that again. 1, 2, 3 over 2. That's it. If I look at the points between A and C, it looks like the vertical drop is going to be 9 and 2, so negative 9/2. Between B and C, that's going to be a negative slope as well, 3. 1, 2, 3, 4, 5, 6. So negative 3/6 or negative 1/2. So I can check it, go down 1 over 2. So now I know the slopes of each. So let's look at point A. Point A is the intersection of two lines, so it will be the solution of those two intersections. So if I look at it, I can see that the y-intercept right here is at 1. So the first line has to be y equals 3/2 x plus 1. Now I know that that same line is going to be the one that I use in B. So it's going to have to be that same line. Now go back to A. So to figure out the other line, it's the slope with 9/2, okay? So up 9 and over 2, okay? So if you see here, I'm sitting at 4. If I go up 9, I'm at 13, and then I go over 2. So that y-intercept has to be at point 13. So that line is y equals negative 9/2 x plus 13. You can double check that. I mean, it goes through the point, what, 2, 5. So if I were to put a 2 in here, wait, do I get a 5? I do not. Let me check what happened there. So I was sitting at 4. If I go up 9, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I go up 9 from 4, and I'm towards 13, then I go over 2, that should be it. So, oh, it goes through the point 2, 4, and that's right. So it does. Okay, so that's correct. So I've got the point A. Now let's look at point B. Point B will be the same line that I've already used, plus the other one down here with the slope of minus 1/2 that has the y-intercept of negative 3. So y equals negative 1/2 x minus 3. Point C is going to be reusing two lines that I already know. Okay, so it's going to be the line with slope negative 9/2 and the slope I just did with negative 1/2. Therefore, okay, so this is sort of going backward. Normally I give you the two equations, you tell me the point. This one is different. I'm giving you the points, you come back and tell me the equations. Let's look at the next one. The next one is harder than it seems. Suppose point D lies on AC such that, what that means is AC is perpendicular to DB. So AC is perpendicular to DB. Find the coordinates of D. Okay, so what it means is there is a line, and this is what you have to be careful of. I'm going to draw this line, and it's perpendicular. Okay, I would love it if that point was 3, -1. I could draw it to where that happens, but that doesn't mean it's true. So I don't know that it hits at 3, -1. Okay, so I can't assume that. So what is it that I know? I know that this dotted line is perpendicular to the line right here. Okay, so that means I automatically know the slope of that line. So I know that the slope of this line is 2/9. Now the other thing I know is I know it goes through the point, what, 2, well, -2, -2, right? So then I can figure out the equation of that line. Y equals 2/9 x plus b. Negative 2 equals 2/9 negative 2 plus b. That's negative 4/9. So negative 2 plus 4/9 equals b. That's negative 18/9 plus 4/9 equals b. So b is what? Negative 14/9. So I know the equation of this dotted line. This line is y equals 2/9 x minus 14/9. So point D is the intersection of two lines. So I know that that point D, is the intersection of y equals 2/9 x minus 14/9 and that original slope, that original line that had the slope, what, minus 9/2 x plus 13. Okay. When I created this, I think I changed the points around a little bit of the triangle. I copied this problem from a book. The only way we know to do is to graph these guys, and I have graphed them, and I can't quite see. But the solution is a little bit more complicated than I want. So I'm just going to leave this problem like this. I won't make you go find this solution right away on this one, because there's the solution right here, 424 over 85, negative 38 over 85. Okay. So anyway, yeah, that's what, it's not quite 3 and it's not quite negative 1/2 kind of thing. So anyway, that got a little bit more complicated than I wanted it to be. Consider this system. For what value of C would there be infinitely many solutions? Okay, so infinitely many solutions means what? It means that these lines are identical. Okay, so one thing I could do, I could put them in slope-intercept form. So the first line, what I get, cy equals negative 2x plus 18. That means that y is negative 2 over c, x plus 18 over c. The next line is going to be what? Negative 8y equals negative 4x plus 36. Y is going to be, when I divide everything by negative 8, 1/2 x minus, so 36/8 is what? 18/4 or 9/2. Okay. Now, if there are infinitely many solutions, okay, if there are infinitely many solutions, then what has to happen? The slopes have to match and the y-intercepts have to match. So I have to have negative 2 over c has to equal 1/2. If I reciprocate both of those, c over negative 2 has to equal 2. Multiply both sides by negative 2. C has to equal negative 4. The other thing that has to happen is that the y-intercepts have to be identical, and that would happen. 18 over negative 4 is negative 9/2. Okay. Another way to approach this is to look at the x and y intercepts. So 2x plus cy equals 18. If x is 0, then you know that the y-intercept is what? 18 over c. And then if I look at the y-intercept, so 2x plus cy equals 18. If y is 0, then you get 9, 0. If I look at the other equation, 4x minus 8y equals 36. Okay. If x is 0, then y has to be negative 36 over 8, negative 18 over 4, negative 9/2. And then 4x minus 8y equals 36. If y is equal to 0, then I get 36 if y is equal to 0, then it goes through 9, 0, right? So what I see here is that for this to happen, these 2 points have to match, and then these 2 points have to match, which means 18 over c is equal to negative 9 halves. Cross multiply, 36 equals negative 9c. So c is equal to negative 4. Same thing. Now, another approach that might be quicker to look at, if I just recognize 2x plus cy equal 18, and what, 4x minus 8y equal 36. If these are identical lines, then they are multiples of each other. So what turns a 2x into a 4x? Well, basically, you're multiplying this top equation by 2. That's what would have to happen. So if I multiply that top equation by 2, then what do I get? So I get that 2x, so 2x plus 2cy equals 18. The bottom, wait, sorry, if I multiply it by 2, I get 4x, sorry, multiplying by 2, 36. And then the bottom equation is 4x minus 8y equals 36. If these equations are identical, then 2c equals negative 8, or c equals negative 4. Okay, so multiple ways of looking at that particular scenario. Consider this system. For what values will there be no solution? Okay, what does it mean to have no solution? It means the slopes are the same. They are parallel lines. So the slopes are the same, but the y-intercepts are not, okay? So if I look at this, for what values will there be no solution? So let's look at this first one, 2x minus cy equals 17. The second one was 3x plus 8y equals 36. Let's go to slope-intercept. Negative cy equals negative 2x plus 17. So y is going to be 2 over cx minus 17 over c. And then over here, you're going to have what? 8y equals negative 3x plus 36. Y is equal to negative 3/8 x plus 36 over 8 is 18 over 4, or 9 halves. Okay. Now, if there is no solution, these two things must have the same slope. Okay. So if they have the same slope, then you know that 2 over c has to equal negative 3/8. If I cross multiply there, you get negative 3c equals 16, or c is equal to negative 16 over 3. So that's what has to happen for them to have the same slope. Now, if there is no solution, they also have to have different y-intercepts. So if I look at the y-intercept here is at 9 halves, and then if I have c as negative 16 thirds, so negative 17 over negative 16 thirds, that is going to be 17 times 3 over 16. That number is certainly not 9 halves, okay? So all that has to happen, c has to be negative 16 thirds, okay? Solve the system of equations, okay? So let's look at this. 2y, so negative 2y, if I take the first one, negative 2y equals negative 5x plus 11. So y is going to be 5 halves x minus 11 halves. Okay, so if I go to negative 5.5, that's going to be my y-intercept. And then I have to go up 5 over 2. So up 5 over 2 right there. And then 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. Okay, so I've got some estimation going on here because I'm not exactly landing on a grid line. So all the more reason to try to be as accurate as you can. And try to get that as accurate as I can. There we go. Okay, if I take the next line right here, I moved the grid. See if I can get that line back. There we go. Okay, now let's take this next line. This is going to be what? 3y equals 2x minus 11. So y is going to be 2/3 x minus 11/3. This is a place where I do prefer mixed fractions. This is what? 2/3 x, and that's what? 3 2/3 minus 3 2/3. So minus 3 2/3. Now, if I go back, I graphed this line in red. Let's see if I can change that real quick. Change that first one to blue since that's the blue line. And now let's go back and do the red one. Okay, so negative 3 2/3. Negative 3 2/3 is somewhere right there. The slope is 2/3, so if I go up 2, 1, 2 over 3, up 2 over 3, up 2 over 3. Back up, I made a mistake on this one. Up 2 over 3, up 2 over 3, and then go down 2 over 3. Got that, down 2 over 3, down 2 over 3, something like that. So I need to go back. How is it my line keeps changing color? This line, I wanted that line to be blue. Now, insert line. I want the next line to be red, something like that. Now here's one of the cases where it really mattered that I was trying to be as accurate as I could. That's why I kept making mistakes and trying to correct them. My y-intercepts were not on grid points, okay? And so I went ahead and graphed it, and it does look like to me, if I did everything right, that maybe this solution is 1, -3. Okay, that is my proposed solution. This is one of those that I certainly would check it. So let's check it out with the first equation. 5 times 1 minus 2. So minus 2 times -3. This is 5 plus 6, which is 11. That works, okay? Let's check the next equation. Minus 2 times 1 plus 3 times -3. This is -9, -2. This is -11. That does work, okay? So if you were very accurate with this guy, even though there was some estimation going on there, we were able to get a right solution. Let's try this one. 25x plus 50y equals 150. 75y equals 50x minus 125. okay? What I can do here, if I look at it, it looks like there's some redundancy in terms of factors, okay? So it looks like I could factor out a number, or I could just say, let's take this approach. This is in standard form, okay? So let's look at this line, X and Y. So when the X value is 0, okay, then the Y value has to be 3, right? When the Y value is 0, then the X value has to be 6. Okay, so I know that that line goes through those particular points. So 0, 3, right here, and 6, 0. So that means the slope of this line is -1/2. So if you go, anytime you go up 3, you go over 6. So up 3 over 6, right there. Okay, so let's draw that line. Insert shape line. So this is just illustrating you don't always have to go to slope-intercept form. You know, in this line, it was in standard form, and I saw that once I set a value to 0, everything was going to work out to get nice even numbers there. Now let's look at this next line, same thing. Okay, when X is 0, you get what? 75Y equals 125. So Y is what? 125 over 75. That is going to be what? 5 over 3, right? If you divide them by 75. So that number is what? 1 2/3. Okay. If I look at, so that's 1 2/3, that's my y-intercept. What about my x-intercept? When y is 0, you're going to get 50x equals 125. So x is 125 over 50. Divide those by 25, you get 5/2. So, you know, 1.5. So if I look at this one, 0, 1 2/3. So 0, 1 2/3 is somewhere right in here. And then 1 1/2, 0 is somewhere right here. Okay. Then if I look at it, what is the slope of that line? Let's try figuring out the slope. You're going to get what? 75y equals 50x minus 125. Y is 50 over 75y minus, what was it? 125 over 75 is 5/3. And so 25 goes in there, it's what, 2/3? So y is 2/3. Is that right? That it's, yeah, I got to check this. 2/3. Y is 2/3 x minus 5/3. So the first one had a negative slope. The next one has a positive slope. So what did I do? I did something wrong in finding these. The red line that I'm showing you there has a negative slope. Let's do that again. If the y was 0, if the x was 0, then this number is negative. Sorry, -1 2/3. So that was off. So -1 2/3 is somewhere down here. Okay. So in this one, I'm looking to see what I'm going to come up with. It doesn't appear to me I'm going to get an exact answer. Let's just see. Slope is 2/3. So if I'm sitting this point, I have to go up 2 over 3. So 1, 2. So up 2, 1, 2 over 3. 1, 2, 3. Somewhere like there. Okay. So maybe it's going to hit that point right beneath it. So let's insert this line. So again, there's some estimation going on here, trying to hit all of these lines. So I'm not sure with this one, okay, based on my accuracy, because I was guessing where that 2/3 and that 1/2 was, okay. Let's go and see if I can make it a little bit better. what if I know it went through those 2 points, okay? Trying to make it go through those 2 points. So I'm thinking, okay, if I did that the best I can, does it go through 1, 2, does it go through 3, 1.5? Okay, so that's my guess. Is it 3, 1.5? That is my guess, okay? So let's try that. So 25 times 3 plus 50 times 1.5. So that's going to be 75 plus 75. That is 150. So I must be living right to get that one. Let's look at the next one. 75y. So 75 times 1.5 minus 50x. So x was what, 3? So what does that equal? 75, let's just do it on my calculator. 75 times 1.5, 75 times 1.5 minus 50 times 150, negative 37.5, and it should be negative 125. So did I not? I did not do that right, or it's not the right answer. So 3, 1.5. So if I do, so 1.5 was y, yep, and 3, so that's 150. That does not work. So I don't get an answer there. So what I'm seeing here is this is an example where graphical is not always the best method, okay? It's the best method when the point lies on an exact line. In this case, it does not. So I don't really get the best result there. So on a test, I'm probably not going to give you something to solve graphically that's not good to solve graphically, because we have other methods as we go further. What you would do here in this case is, if you can't determine it graphically, you'll go to one of our other methods in order to figure that out. Now, I'm taking a different look at this. When I was estimating these points, negative 1 2/3, 1.5, let's go back to this line. At one point, I estimated this point right here, okay, being a fit. And then if I saw this point being a fit, okay, it could be that I'm getting closer to 4, 1, okay. And again, there's some guesswork here. So don't move my grid, okay, when I'm trying to be exact with my graph, okay. So it could be the case if 4, 1, is that the solution, okay? In this case, you could plug in a 4, 1, and it would be the solution to this particular one. So again, this just shows the shortcoming of a graphical approach, okay? So again, these are just here to show you that this is not always the best solution, okay? There's a more algebraic, 2 different algebraic solutions we're going to hit later, which are more accurate in that case. Let's take a look at this word problem. Rock and Bowl charges $275 per game plus $3 for shoe rental. Super Bowling charges, so I think this should be $275. Okay. Super Bowling charged $225 per game and $350 for the shoe rental. For how many games will the cost to bowl be the same at both places? What is the cost? Define the variables and write a system of equations. Most people prefer just to go with X and Y here. So you've got costs going on, the cost per game, and then you've got a cost for shoe rental, okay? So so we'll let X equal the number of games, and Y is going to be my cost. So for the Rock and Bowl, you know the cost is going to be what, $275 for every game plus $3. And then for the Super Bowl, just change this to a different color. You know that the cost is going to be $225 per game plus $350. So I want to figure out, when will the cost of these be identical? So I'm going to be real careful in trying to graph these because I do see some decimals going on here. So 2.75, you know that is what? This is what, 2 3/4, which is what, 11/4. Okay. And then 225, 2 1/4, that is 9/4. So that's helpful with my slope. Okay. So in the first one, if I go to 3 to graph this guy, so let me make this a little bit smaller. So if I graph this guy with a y-intercept of 3, 4, 3, which is right here, okay, the slope is what, 11/4. So 3 plus 11 is 14, go over 4. Okay. And then 14 plus 11 is 25, go over 4. Right there. Okay. So that should give me the first line. So insert my line going through these points. Okay. Now the next one, the y-intercept is at 350. So 350 is right here. The slope is 9/4. So if I go up 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9 over 4 right there. Then go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 4 right there. See if I can insert that line. Let's try that again. Insert line. And something like this. Okay. So it looks like to me, I am hopeful that they intersect right there. Okay, that would be what, at 1, 6? That's my question. Okay, is that the place where they are the same? Okay, so if I were to use a 1 in this first equation, okay, so if you plug in a 1, I don't think, is that, did I do that right? Hold on. Sorry, I need to make a correction here as I'm working this out to make it better. I want this problem to solve graphically. For the word problems, I don't want to give you a graphical word problem and then the answer is, hey, it's just not good to do graphically. So let's make a couple of changes. Let's keep the rock and bowl equation like it is, but let's change the Super Bowl to what, 250 per game and 350 for shoe rental. So what that means is this is going to be 250 per game plus 350, so that's 2.5x plus 350. The other thing that's a good idea is I wasn't paying attention. I had already labeled the x-axis. I just didn't have it to where I could see that. So I had the x-axis labeled where I could be a little bit more accurate in my graphing. So let's just regraph both of these real quick. So the first one, the intercept is at 3. So at 3, okay. And then it's what, 11/4. So if I go up 11, so if I go up 11, so I'm at 3 plus 11 is 14, and then I go over to 4, which is right here. So actually it is right there on the 4, okay? And I'm going to connect these dots. Right there. Now the next one, I'm at 350, okay? So 350 is sort of right there, somewhere in that area. And the slope is 2.5, which is what slope is 5/2. So if I were to go up 5, 1, 2, 3, 4, 5, and then over 2, which is sort of right there, up 5, 1, 2, 3, 4, 5, and then over 2 right there. So in this one, something like this, okay, it's going on. So it appears that what 2, and this is what 6, 7, 8, I'm going to guess 850. If that's going to work, 2 and 850, all we have to do is look at both equations. So if I put in a 2 for x, if you put in a 2 for x there, you get 550 plus 3, which is 850. You plug in a 2 for x right there, and you get 5 plus 350 equals 850. So what is the cost? The cost is $8.50, and that is from using 2 games. So this is one of the situations where it took a lot to graph this guy. It took a lot of patience. I made some mistakes. So we're getting the conclusion that graphing may not be the best approach all the time. So we'll spend lessons coming up and trying to verify that by using algebraic methods to solve these guys. Okay?